Welcome to episode 8 of Renewing the Conversation, a series of interviews where we talk to leading industry professionals and experts about renewable energy and heating with a focus on the home and what challenges face the industry and homeowners.
Today we welcome Jez Climas, Head of Renewable Heat at Midsummer Wholesale. We talk to Jez about the uptake of heat pumps in the UK, which brands are the most popular, and what his advice is to homeowners looking to switch to renewable heating systems.
But before we get started, we would like to say a huge thank you to today's sponsor, the Ground Source Heat Pump Association, who are aiming to decarbonise homes and businesses and electrify heating by strengthening the reputation of the UK's ground source energy industry. If you would like to find out more about ground source heat pumps, please head over to their website www.gshp.org.uk, link below.
And don't forget to hit the subscribe button and please show us your support by giving us a thumbs up. Enjoy the interview. Good morning, Jez. Thank you so much for joining us today. It's great to have you on. I know that you've recently joined Midsummer Wholesale. And you've got a role there as head of renewable heating. Can you just tell us a little bit about how Midsummer Wholesale started? I believe it's quite an interesting story with Andy, the founder of the company. And can you just tell us a little bit of background about the company and what you guys do over there?
Well, yeah, so it started quite a while back, about 15 years ago, I think. And Andy was working for the British Antarctic Survey as a climate scientist and very worried about the climate as a result of having studied what was going on. And he was spending our winters, summer in the Antarctic down there, and then living on a boat in Cambridge in the summer here. Living on a boat isn't lovely necessarily in winter. That's the hardest time, but he didn't have to put up with that so much. He decided to electrify his boat living on the Cambridge off Midsummer Common, which is why the name of the company. So he electrified his boat, put PV on it, put in batteries and electric motor. Other people thought that was good, so he did theirs too and charged them for doing it. And it grew from there into a kind of off-grid PV installation business and then a grid-tied PV installation business. The wholesale part of the business kind of took over, and gradually over the years, it became quite a large wholesaler of photovoltaics, mounting systems and inverters. And then it was one of the first ones to start adding in battery storage and EV chargers as well into the range as complementary products to all the solar. Following all of that, they've talked a few times about getting into heat pumps as well as the next thing that's going to be growing as a renewables business. So I got speaking to Andy and he persuaded me to join to help them start the heating stuff, because my background's as a design engineer, designing systems mostly for larger commercial buildings. They know all about wholesaling renewables, and I know all about heating systems. So between us, we've got enough knowledge to, I think, offer something quite helpful to the market.
Tell us about your role and how you get involved in the designing of projects, and what is the split between the projects that you work on that are commercial and residential, and what are the fundamental differences in designing a project that's commercial versus residential, other than the obvious one, which would be size?
What I've come from is designing the commercial stuff, and in that it's all very tightly controlled, but strangely the equipment's not as clever. So the heat pumps for commercial aren't nearly so sophisticated as the ones for domestic, which the manufacturers have optimized the controls so much more for the job they have to do. Whereas in commercial, you have to spend a lot more time figuring out how they're going to be set up and designing the systems around the lack of sophistication of the equipment. Whereas in domestic, it's much more about finding out what the equipment does and putting together complementary components. And it's more kind of assembling a kit rather than starting from the ground up to design the system in more detail. Domestic heating engineering has been dumbed down to some extent partly by the amazing sophistication of gas boilers. The only bad thing about gas boilers is that they burn gas. In every other respect, they're spectacular pieces of equipment. They're so robust and able to deal with being installed badly and still heat everything just fine. There's so little setup required on them, but it's meant, because they're so good, it's meant heating engineers don't have to have the same system understanding that they used to, 20, 40 years ago, where they had to set the systems up very carefully because the equipment was more sensitive. And heat pumps are a bit like that. They're a bit more sensitive to the setup of the system than boilers are. You have to do the heat loss calculations, and you have to make sure there's sufficient flow through the heat pump because you've got higher flow rates. And so there's a lot of skills that are more scarce among heating engineers now than they used to be that they're needing to relearn. I saw the opportunity of stepping in because I have all of those skills. I thought by moving into this sector, I could help move on and pre-solve some of that, shortcut some of that for heating engineers, and help the systems be designed well by trying to provide resources and tools to help those domestic heating engineers pick up the stuff that they're not so good at anymore.
So what is the demand comparison from homeowners that are retrofitting versus new builds or self-builds?
So I'd say at the moment, retrofit is bigger than new build. There's not loads and loads of heat pumps going in new build right now because of the way that the part out of the building regulations, which is the part of building regulations that it covers conservation of fuel and power. Because of the way that's currently structured, putting in a heat pump doesn't help very much. At the moment, it massively overestimates the carbon emissions associated with electricity compared to reality. Putting a heat pump into the model for compliance for Part L does show slightly lower carbon emissions than using a boiler, but actually not a lot lower. So it's not a very cost-effective way to meet those regulations. And most people building new houses, most of the house builders are, these big house builder companies, their target is lowest cost. So they'll find the cheapest way to meet whatever regulations you put in front of them for the most part. That's meant boilers haven't really caught on, particularly with the big house builders. There are some smaller house builders focusing on more eco-home type things, and they are putting in heat pumps. But at the moment, it's mostly retrofit.
So what are the biggest concerns you hear from installers, especially if they're dealing with a lot of retrofits?
I think the biggest issue for people moving into it is that they're not used to doing heat loss calculations, and they're very nervous about the heat loss calculations they're doing. So whereas with boilers, it's very common for a heating engineer will come into your home, they'll have a look around, they'll take a look at how big your house is, and then they'll just select a boiler size without doing any calculations. That can't really be done with heat pumps because the boilers that they'll choose will be 24, 30 kilowatts, 35 kilowatts output boilers. The heat losses of homes are much, much smaller than that in reality. So, my home, for instance, this is, it's a 1969 mid-terraced house that has uninsulated cavity walls because it's difficult to do that in a terrace. I've put in relatively new windows. I've insulated the loft, and the heat loss of my house is a 3-bedroom home, but the heat loss of the house is 4.5 kilowatts. But I've got a 30 kilowatt boiler because that's what the previous owner put in. And it's nuts. But that's where we're at. But you do those heat loss calculations, but you have to be confident in doing them. And I think that's a difficult thing for heating engineers to pick up. Even ones who've been doing it a while still have a tendency to be quite cautious and end up putting in bigger heat pumps than they need. So, I reckon if you asked a bunch of heat pump installers to come and design a heat pump system for my house, most of them would come up with a 6 or 8 kilowatt heat pump and not a 5 kilowatt heat pump. It's the consequences of getting it wrong that drive this. If you get it wrong and the heat pump's too big, then it runs a bit less efficiently than it should because it cycles a bit. It's a bit bigger and more expensive and noisier than it could be, but none of those is a catastrophe. Whereas if the heat pump's too small and in January we're all freezing and wrapped in blankets and turning on a fan heater, then that heating engineer is getting an angry phone call. It's very difficult to try and squeeze down to a more accurate heat loss sizing, but without risking more instances of it being too small. And you're always dealing with that uncertainty in retrofit, that it's hard to know the constructions of the walls, and different types of blockwork in a cavity wall can cause a fairly big difference in the U value of the wall. It's practically impossible to know if you're visiting and doing a heat loss survey whether they're high performance aerated block or dense concrete blocks. They're always going to have to make some conservative assumptions to avoid difficulties, unless we can start getting into measured heat losses. Midsummer are looking at ways to fold into our design software hopefully a less conservative method of looking at infiltration so that less heat pumps are oversized. So we've got some funded research going on with UCL through a government funded New Energy's project, then they're looking at ways to make better estimates of infiltration rate for heat loss calculations for us. They're kind of doing a literature search at the moment. So I'm hopeful we'll have better answers on that, so that our design software that we're going to be offering free to installers is going, if they follow the process of our design software, it should give less conservative but still acceptably good heat loss calculations. That's the plan. So we're trying to bring some academic rigor and improvement to the whole thing, but having to be quite cautious, because we don't want to leave people cold like everyone else.
Do you see homeowners asking the right questions, and do you see the homeowners really being as engaged as you think that they should be in that early part of the process?
I mean, I really feel for homeowners some of the time with this. So, a recent example was one of our customers who's been a solar installer has employed a heating engineer and are moving into heat pumps, and they've been asking the distributors, the wholesalers of the heat pumps, to do the calculations for them. And so I did a calculation for them for a house that they're offering to sell a heat pump, and another distributor had done it and come up with an 11.2 kilowatt heat pump, and I did it, and I was kind of umming and ahhing about whether it was an 8 kilowatt or not. It was, it was there or thereabouts. If it was my own house, I'd have gone for the 8 and been fairly happy with it. As I'm giving the answer to someone else, I was tempted to be a bit more cautious, but it certainly wasn't 11 or 12 kilowatts heat loss for this house. And the poor homeowner, if this company goes to them, they're confused. They don't know. They don't really have any conception of what 8 or 12 kilowatts looks like. And they would have no idea what the heat loss of their house is. And so it'll come down to who gives them the most convincing patter that their calculation is right. But, the cost difference between heat pumps of those capacities is quite large. It's hundreds of pounds cost difference. That homeowner's then having to decide, is this person who's offering me an 8 kilowatt heat pump nuts, and am I just going to be cold? Or is this person who's offering me an 11 kilowatt heat pump being excessively cautious, and I'm going to spend loads of money to have a less efficient heat pump? Our heat pump software has kind of grown out of our PV design software. And one thing that's been key with that we've had feedback from installers about is that it produces a design report that they can show to the homeowner, that the homeowner sees it's definitely been designed. It's very obvious it's been designed, and some work has gone into that, and it's well presented. And the same on the heat pump. So they get a formatted report which shows room by room the heat loss of each room and how it's being met, and that overall heat loss is fine, and it lists what the constructions are. If they've gone through that process, hopefully they've done a less conservative calculation. They've done the calculation properly because it's nice and quick and easy to do. And then they've got a report to show the homeowner, that the homeowner looks at that and goes, okay, this is a professional job. If someone else has gone 12 kilowatts, then that homeowner will have more confidence in the person who's shown them something that looks more considered.
So which heat pumps does Midsummer Wholesale sell? Which brands? And which one would you choose to put into your home?
The first ones we had were Samsung and Mitsubishi, and then we've also added Valent to the range. Practically every heat pump on the UK market, there's a reason it exists. Some are more expensive and have good features. Some are less expensive but might be better value in a lot of cases because of that. The Samsungs, we were one of the first ones we picked up, and that was because they're kind of very good efficiencies. They're right up there for best efficiencies, but they're also very good value for money, and they're very reliable. They're quite small and light compared to some other models. So they're relatively easy to install, particularly if you've got to get them to an awkward spot. Well, Samsung has an insane R&D as a whole business. It's got thousands of people working in R&D and billions of R&D spend probably. We can be sure that the pipeline of future products will be there, that they won't do heat pumps for a bit and forget about it, because they're really good value for money. If I was paying normal price for one, I'd probably get myself a Samsung here. So Valent and Mitsubishi occupy a fairly similar part of the market, really. They both make more expensive but very quiet heat pumps. So one of the downsides of the Samsungs compared to some of the competitors is they're a bit noisier. Okay. So what I suggest to people with those is you can schedule quiet mode on the controller. It's very easy to schedule it. And I suggest putting them into quiet mode for the bulk of the year, and then only letting them be noisier right in the depths of winter when you need more output. In December and January, people have their windows shut, so the noise isn't such a nuisance to anybody because people aren't opening their windows and letting the noise in. The Valence and Mitsubishis are both quiet, and the Valence, the new Aerotherm Plus, is especially quiet, even quieter than the Mitsubishi. And they both look quite nice as well for a heat pump. Is in the eye of the beholder, but I think you'd struggle to find anybody who says any heat pump's a beautiful item. What's really great about the Valent Aerotherm Plus, which is why we brought it into the range, is that it uses propane as the refrigerant. Historically, refrigeration was often done with CFCs, and they destroyed the ozone layer, and everyone realised a bit late. That one's kind of been solved. So CFCs are almost completely out of circulation now, and certainly no heat pumps on sale in the UK have CFCs as the refrigerant. Another characteristic of CFCs is they have a very high global warming potential. So 1 kilo of that refrigerant released into the atmosphere has the same global warming impact as about 10 tons of carbon dioxide as a powerful greenhouse gas. They've been replaced by HFCs, so that's hydrofluorocarbons, so without chlorine, which are better in that they don't deplete the ozone layer, so that's great. But a lot of the common ones that were around a little while ago and very common still had quite high global warming potentials. So 7 or 8 years ago, practically all the heat pumps on the market used R410A as the refrigerant. And I can't quite remember what R410A is as a chemical, but it's the global warming potential of that's 2088, I think. So it's 1 kilo of that being released to the atmosphere is the same global warming effect as 2 tons of carbon dioxide. So although it shouldn't get released, and for the most part it doesn't, just if it ever does, it's fairly bad. There's been a move to try and keep bringing this down. So now most heat pumps on the market in the UK use R32, which is difluoromethane. So it's carbon with 2 hydrogens and 2 fluorines. That's better again. So that's 675 is its global warming potential. So, a third of what R410A is. So it's all moving in the right direction. And that's the most common now. If you can move to natural refrigerants like propane, the global warming potential of propane is 3. So it's almost got a negligible impact if it leaks. R32 is a little bit flammable, and propane, as we all know, is really quite flammable. The heat pumps have to be designed carefully to be extra safe because they do contain a flammable gas. Money no object, I'd probably have a Valent Aerotherm Plus.
So in retrofit projects, obviously when you're putting an air source heat pump in, or heat pump in general, one of the big other upgrades that typically happens is the hot water cylinder. What role does that play in the overall efficiency of an air source heat pump system?
One of the issues is that cylinders for boilers, so where people have got a hot water cylinder that they've been heating with a boiler in the past, those cylinders, they're heated by an indirect coil. So the cylinder's the volume of water where cold comes in at the bottom, hot comes out the top, and it's heated by an indirect coil. So there's a coil of pipe within that heating water goes through. So it comes in hot, it goes through this big coil, and it comes back out having dumped some heat into the hot water, and that's how the tank is heated. Now, the surface area of those coils for a boiler heated tank is typically about 0.7 or 0.8 square meters. That works because the boiler can go very hot. It can go up to 80 degrees. If it's only heating water to 50, that means it's 30 degrees warmer than the water it's trying to heat. So it can transfer enough heat through a fairly small coil. With heat pumps, the efficiency of a heat pump, the COP, which is coefficient of performance, the ratio of electricity into heat out, that gets worse the hotter you make the heat pump run. When a heat pump is heating water, it wants to be as close as possible to the temperature of the water you're heating. So you want to be running the heat pump through the coil at, say, 55 to get water at 52. So there's only a 3-degree temperature difference, and the heat pump's running as cool as it can. And what that means is that the coil has to be much larger so that it can transfer the heat that the heat pump's putting in at a much smaller temperature difference than with the boiler coils. The most common conclusion to that issue is if someone has a hot water cylinder, no matter what condition it's in, it normally gets taken out and replaced with a heat pump specific hot water cylinder.
So when you're designing and putting together a plan for a homeowner with regards to renewables, as part of that plan and that project management, do you talk to them about how different their experience is going to be after? So after the installation, after everybody's left, how does their living experience alter in that the mindset of how to manage the heating in the property and what they can kind of expect going into their first winter?
The key things, I think, to talk through with the homeowner when they're being sold a heat pump, and for the homeowner to be hearing, is space. So there's outside space. The heat pump needs somewhere to live, and they're not small. It's typically about a 2 metre by 2 metre plot of land it ends up needing, because it takes up a chunk of that space, and it needs access around the sides for maintenance and for air to get in. And it needs space in front for the cold air to dissipate, so it's not recirculating in the cold air and running less efficiently. So there's a space take outside, and you can have things that occasionally go in that space in front, but it's good to get it next to a path, or if it's next to a patio, that's probably all right, because patio furniture is porous enough that it won't ruin it, but you can't stack all your patio furniture up against it. Then also the inside space, that a lot of people don't have a cylinder. Over 2/3 of homes have a combi boiler at the moment. A lot of them did have a cylinder at some point, but have got rid of it to get the air encumbered space to stack towels in. Yeah, the experience of low temperature heating, like we talked about with hot water, where the heat pump to get the best efficiency out of the heat pump, it should be running at as low a temperature as possible at all times. It always wants to be putting in the water into your heating system only just hot enough to keep your house warm. The warmer it is outside, the lower the temperature needs to be to heat your house. When it's very cold outside, the water from the heat pump needs to be at its hottest, so your radiators put out enough heat, which means that the efficiency of your heat pump varies a lot through the year with the weather conditions. And in spring and autumn, it's actually very efficient. Whereas in the depths of winter, it's at its least efficient, because it's producing the hottest water, taking the heat out the coldest air. That needs to be set up, and the homeowner needs to understand that's what they're getting, so that they're not expecting to touch their radiator and for it to feel warm in October. It'll barely feel any warmer than the room, but it'll be putting out enough heat to stop their house getting cold. It's better to run it a lot and let it gently push heat into your house at roughly the rate it's going out, rather than the kind of intermittent heating that I think a lot of British people are used to, where they let the house get cold and then they chuck heat into it really hard, and in half an hour it's got most up to temperature. And actually, I think there is a real comfort benefit to that low temperature, slower heating method, that all of the building fabric around you, all the walls and the ceiling and the floor, are at the air temperature. You're not getting the convection currents that you get from a very hot radiator driving air movement through the house. So it is more comfortable if you let your house do that. And it's more efficient with a heat pump, because it doesn't have to run as hot, because it doesn't have to kick the heat in hard. It just gently keeps pushing heat in and runs as low a temperature as possible. People are going to need to get used to that. And if they go away for the weekend, it is a good idea to set the temperature back when they go away. But instead of expecting to come in the house and turn the heating on and be warm soon, they kind of think about getting it on their phone and setting it to warm up a couple of hours before they get home.
On the installers that you're working with, do any of them kind of automatically think of offering homeowners a kind of almost like a more turnkey solution or package, as in, they don't just come to you to order a heat pump, but they come to you and say, okay, look, I'm going to be putting in this heat pump, I'm thinking of having this solar array to support this heat pump, etc. Is that kind of the most optimal way of going about looking at heat pumps as kind of more of a kind of overall solution, thinking, okay, I'm going to be putting in a heat pump. Should I be looking at putting in a solar panel with that? What other changes should I be looking at to kind of make this more of a complete package that works long term? And
possibly batteries into that mix too.
This is a really big thing, that there's really good synergies between installing solar and a heat pump. That there's a lot of the time, it's very sunny now, but we haven't got the heating on, but it could be quite easily, it could be 10 degrees and this sunny in September and October and again in spring. And so you do get days where your PV production could quite easily run your heat pump. Yeah, my house, I've designed a solar array. I haven't installed, but I can get about 3 kilowatts on my roof. And as we discussed earlier, my heat loss is 4.5 kilowatts. So I'd be putting in a 5 kilowatt heat pump. On a sunny but cool autumn day, the PV would be producing more than the heat pump would be drawing. I'd be able to run my heat pump and the solar would be covering it. I'd also be charging the battery that then when the sun went away at 5 in the afternoon. That they could then draw out the battery to run my heating with stored electricity. The whole package works together very nicely.
When we put our air source heat pump in, it was a very logical step for us to put the solar PV array in, because we were banking on obviously the solar driving the heat pump during the day, because we're basically at home a lot of the time. As part of that mix, I did actually look at a battery pack to go along with that. And this is 3 years ago. I think battery technology has come along quite a long way from that point. But where I struggled to stack things up was from a return on investment perspective. It just never seemed that you were going to fully recoup the actual investments in the battery. There were no grants or anything that actually goes along with that. So how does that ROI actually, can batteries end up paying for themselves in any way?
I've done the calculations a few times, and I'm the heating guy, so not quite my area.
Fair
but
enough.
From looking at it, what I have looked at, it seems to be about a 10-year payback for PV with or without a battery. So you spend the extra on the battery at the moment, and that does a single install. Because one thing that's made it a bit cheaper on fresh installs is, well, for a start, the electrician's already there, so you haven't got to pay an electrician for the PV install part and then pay an electrician for the battery install part. They're there and it's one process. Hybrid inverters have become really common now. So instead of having an inverter attached to your battery and an inverter attached to your PV, they share one. So what an inverter is, it's the device that converts from direct current to alternating current. So all of the sockets and electrics in your home is alternating current AC, and all of the electrical distribution grid out on the street and so on is AC. PV and batteries are both direct current devices, DC. What getting a hybrid inverter means is that your PV can directly charge your battery through the DC, whereas if you've got a separate battery and PV system, it goes DC from the PV through an inverter to the AC, then through another set of electronics to charge the battery in DC, and then when your battery discharges, it goes through an inverter to get to AC. So there's a lot of and all of that introduces small losses. They're very efficient devices, but they're still only 99% efficient. You're losing a few percent on the power. But hybrid inverters, there's a single inverter device, so that's cheaper already, and it's shared by the battery and the PV, which makes it more efficient.
I guess that vehicle to grid then starts becoming a far more attractive proposition, because then you've got one vehicle that's basically can effectively act as your battery overnight. I still think we're maybe some time from vehicle to grid being a reality, but that could be a potential solution.
I think that's very interesting as a thing to consider, is what vehicle to grid might look like, because typically the home battery that someone might get installed with their PV system stores 5 or 10 kilowatt hours, that sort of amount. A car typically has a 70 kilowatt hour battery or similar. I think that's what a Tesla Model 3 has, is 70 kilowatt hours. If you set a vehicle to grid system up, a theoretical one, because they're not very available right now, but to float around in the top 10 kilowatt hours of that car battery most of the time, it doesn't drastically affect the range. And so most of the time, day to day, the car becomes no less usable, even if it's down to 60 kilowatt hours in the morning rather than the full 70. Suddenly it's offering the same amount of storage as one of the more expensive batteries that someone might buy as a home PV battery. So I think the possibilities for vehicle to grid are big because of that. It seems to be struggling to get off the ground, and I don't know too much about why, because I can see huge potential in it for that reason.
So what are you most excited about? I mean, I know we've got COP26 coming up, and hopefully we'll see some policy changes come out of that. Do you think that we're hearing a lot about COP26, but as a layman or a member of the public or a homeowner, is it really going to affect me directly? And is it going to affect you directly within the industry? Are you expecting anything to come out of that will either bolster your industry or help push renewables forward?
The government has some big targets, and Boris Johnson said some very impressive things in terms of targets, but it doesn't have the meat of policy behind it. 600,000 heat pumps installed every year by 2028 is necessary for us to hit our climate goals in this country. But at the moment, there's definitely not the policies in place to grow the industry at that rate. So we need to see those policies emerging. I'm hopeful that we are going to start seeing some of that. An easy win is getting new build houses all installing heat pumps as part of new build housing, because it's so much easier when you're not having to modify systems to convert them to heat pumps. But if they're designed to work with a heat pump from day one, there's no radiator replacement because all the radiators are just new ones. So get all the radiators in, designed to run at 45, get the heat pumps in, get all the pipework designed to run at the 5-degree temperature difference heat pumps like, as opposed to the 10 or 20 that boilers like. It doesn't really add a whole lot to the cost of a new build home. And it means that the people buying it don't have a big retrofit cost in the future. I've got friends who are looking at buying a new build home at the moment. Their minds are blown that they're offering homes in 2021 and homes that are going to be completed in 2022 that have gas boilers, and they're just going, well, so am I looking at a whole heat pump upgrade process the first time my boiler breaks? It's insane. So I think getting new builds straightened out is low hanging fruit. It's easy. It doesn't add much cost to anything, and it gives an opportunity to just skill up the industry as well, because you'll get more people. You'll increase the size of the heat pump installation market, and more people will be doing the on the ground installs and getting those skills. So I'm hoping that they flesh out all of those policy areas of regulation support and training support.
So just as a final thought from you, Jez, what kind of advice would you say to an installer that was coming to Midsummer Wholesale with regards to, how should they approach you to get a good offering for their clients, and what should they be thinking about when they're thinking about doing a renewables project for their customers?
Anybody watching this, if your boiler breaks, please don't get another boiler. It's too late for boilers. We can't be installing new gas burning appliances in our homes in 2021 and beyond. The key thing really is to lean on our experience and knowledge. We're going to have really nice software that's going to make it very easy to do good heat loss calculations and provide good marketing tools to help you win the job with the homeowner. Do ask me about that. I've done lots of heat loss calculations, and I've taught tens of people to do heat loss calculations already. We will be offering help and support with getting those right and doing that well, and choosing the right heat pump and choosing the right components and kit to meet the needs of the homeowner. That's really what I got into this to do, is to provide that help and support. There's a big opportunity for installers of renewable technologies, whichever ones they currently install, whether it's PV or heat pumps, to either expand their skills to bring in the other technologies, or partner up with other companies or individuals to broaden the range of the offer. Because of that synergy between solar and heat pumps, it just makes sense to be able to offer all of that to the homeowner, even if they can't take it all up straight away. Lean on the expertise of your suppliers, and Midsummer are very good on supporting you in getting the kit right, getting the calculations right, and understanding the systems and what's available, and getting you moving in the right direction.
Thank you so much for your time today, Jez. We've really appreciated you taking some time out of your day, and it's been really interesting to hear about what's happening over at Midsummer Wholesale. Is there any way that people can contact you? Is it just through the website? Yeah, so
midsummerwholesale.co.uk is our website. The phone number's on there. Always on the end of the line. We're there. There's lots of us. We're ready to help. We haven't quite got our heat pump design software out, but that's not far off, a couple of months probably.
Watch this space.
Yeah,
it should be out this autumn 2021, so it's going to be good. Thanks for having me on. It's been really fun speaking to you guys.
That's
cool.
great. Thanks,
Thank you
Jez.
so much. We really enjoyed it. Thanks very much. Take care.
Cheers. Bye.
Bye.